Hi all, welcome to part 11 module 2 computer network. So we were discussing the pipelining concept of or the sliding window protocol for flow control, and so far we saw the sender window only, and sender window in case of stop and wait where it is sender window is found to be 1, where to improve the efficiency we saw that we can increase sender windows to some maximum value of 1 plus 2a. So the sliding window protocol is actually a theoretical concept. So what we seen already is a theoretical concept, and which talked about what should be the sender window size only, that is 1 plus 2a, and it is to be increased to 1 plus 2a to increase the efficiency of so-called stop and wait protocol. But when it comes to practical implementation, we have to consider the receiver window also. Like the practical implementation of the sliding window protocol explains also the size of the receiver window, and the window varies accordingly the efficiency related problems. And practically it is implemented in two protocols, mainly the go back N ARQ and the selective repeat ARQ. So two variations were there, go back N or GBN, selective repeat SR protocol, and ARQ is that general term when you use the timer and all. So the protocol is now ready to work in a general noisy channel. So that is the meaning of ARQ protocol. Yeah. So now we will see the significance of name everything when we move on to its discussion. So let's take that example first, the pipelining and error recovery procedure, the effect of error when the receiver window size is found to be 1 and large. So just like stop and wait protocol, initially we will assume the receiver window to be 1 and we will see how it is working. Then we will increase it to some large value and we will see its performance. So here see the first diagram is about receiver window size to be 1. Let me take the mouse pointer as pen. Yeah. So here the receiver window size is 1, means the receiver can buffer 1 frame at any time, and immediately after processing the currently buffered 1 frame to the higher layer, and if everything is fine, then it will take the next ones like that. So at any time it can keep only 1 frame in the receiver side. So that is the meaning of receiver window size. Just like that stop and wait, it is a very trivial case, but we have practical protocol with this assumption. So it is something like this: from the sender side, the frame number 0, 1. So what happened here is, yeah, here there is no assumption about that sequence number. We are not restricting it, simply we are providing different sequence number as and when needed. Okay, so we keep on assigning, and now 0 you start sending and it is being received successfully, fine. So whenever the receiver processes the particular frame number 0, it will be sending an acknowledgement back, that is acknowledgement for the 0th frame, but actually acknowledgement number is to be taken differently. So here it simply means that acknowledgement for 0, but normally acknowledgement number has to be the sequence number of the next expected frame. So the next expected frame is 1, so it is to be 1. Okay, but in the textbook it is given like that, but this simply means that there is an acknowledgement, that's all. Similarly for this will be like 2. Okay, and now so these two are processed, right? So now it's time for the frame number 2 to reach. Okay, 2 also reached. Now when it processed 2, it find out that this frame number 2, some error happened. Either it may lost on the way. So okay, lost and all, timeout will be handling. Okay, whether it is lost or when it is being error detection algorithm is run, some error is being detected. Now the receiver can't handle the subsequent frames because the receiver window is just only one frame it can accommodate at any time, and it found that this frame is error. Now if it is taken the next one, see, frame number 3, it will be some kind of out of order delivery, right? Because frame number 0, 1, then 2 is supposed to be delivered to the higher layer. So what the receiver will do is, the receiver will simply wait until this frame number 2 is correctly delivered, right, at the receiver side. So actually 3 in between, without knowing the fact, because you are implementing the pipelining concept, right? So without waiting for acknowledgement of 2, you will send some more frames, right? So this 3 you are sending, but even though you are sending, as it's reached the receiver will simply discard that 3. So that 3 is discarded, similarly 4 is discarded, 5 is discarded, 6 is discarded, 7 is discarded, and 8 is discarded. Why this many discarded? Because in this case I think this 1 plus 2a could be like 2, I mean that window could be I mean center window, this is our center window, could be able to handle this many things, right? That is 2, 1, 2, 3, 4, 5, 6, 7. That means 8 minus 2 plus 1. Okay, so 2 to 8. That many are in a single window. It can send say 7 frames. So here it is just taken as an example, but I was trying to correlate with that. So 7 it is being sent, right? 7 in the sense starting from 2, 6 more. 1, 2, 3, 4, 5, 6, 7. So after this 8th frame, I mean after sending the 7th frame, then it will definitely wait for the acknowledgement of the first one being sent, that is 2. And if acknowledgement is not coming for 2 till that time, so the timeout timer will now run, immediately after sending every frame, some timer will be started at the center side. So all those concepts are still here also. And for 3 also one timer started, but mainly we highlight the timeout timer for the frame number 2. And it started and it is expired at this point. Even though it is expiring some later point, it is something decided by the center window also. But I think in this example, the center window, they are not giving much attention. So they are just focusing on the timeout timer. So the timeout timer for 2 is expired at this point, right? So till that, it will keep on sending some frame, assuming that it will be getting some acknowledgement kind of thing. But we didn't get the acknowledgement for 2 yet. So for 2, the acknowledgement will be acknowledgement ACK3. So when you implement that acknowledgement number correctly, it has to be ACK3, and see that is not coming, right? So what you will do is you will retransmit not only this 2, but you have to retransmit the entire thing that you transmitted so far. So that is very important. So that is the problem here. So right now you are at the frame number 8. You send frame number 8. From that point you are going back towards this last unacknowledged frame whose time expired right now 2, and this entire window, right? If we are following that window concept, this is our window of 7 frames you are supposed to retransmit. So 2, 3, 4, 5, 6, 7, 8, everything you have to retransmit, and if everything is coming fine, then you can go for, or you can slide the window towards the 9th frame, right? So that is the thing. So why it is so? Because actually only 2 is lost, but the receiver is forced to discard the subsequent frames also, because the receiver window is just 1. Now when you improve this receiver window size to a value bigger than this one, so I am making this receiver window large in the sense, so that is somewhat proportional to center window. You don't want to make it more than the 7, right? Because maximum 7 will be coming. So what you can do is, so that is this variation, as usual this second one. So here as per the acknowledgement concept I discussed, this has to be acknowledgement number to be 1, for this it is to be 2. So this is frame number 2 is again came as erroneous. So if it is detected at the receiver side to be error, then the receiver can send a special acknowledgement called NAK, negative acknowledgement. Okay, so this is negative acknowledgement. So normal acknowledgements were now positive acknowledgement. So negative acknowledgement says that it's saying to the sender that this particular frame arrived with some error. Like I found some error, or my error detection algorithm finds some error with this frame number 2. So negative acknowledgement, you have to mention the correct sequence number of the frame which received with some error, or timeout timer. Anything will happen. So if timeout timer expires, okay, after that you can selectively you can send that to, or this immediately when you are getting, so negative acknowledgement is actually speed up the process. So whenever the sender is getting negative acknowledgement, immediately it can send that 2 alone. Now what is happening for, actually only 2 is received with some error, right? And for that 2 specifically you send a negative acknowledgement with its sequence number. So this particular frame you please send me once again, because some problem with this. Now what the receiver will do for 3, 4 and 5 and subsequent frames, if they arrive, it will frame the these frames are being buffered at the data link layer. In the sense, now we increased your window size, receiver window size, to some better value, maybe maximum to this 7, so whatever it is. So that means space is there in the receiver window. So this 3, 4 and 5 will simply wait at the receiver side. You don't have to retransmit them just like this. You are not, the receiver is not going to discard them. So what the sender can do, either the sender will start the timer, and when the timer expires, it will retransmit this to, or whenever it is receiving this negative acknowledgement, it will understand that some problem with the 2, and that time it selectively retransmit that particular frame. So this is the concept. The first concept I explained is called go back in. I hope you understood. Whenever there is a problem, I found from the sender side, the sender understood that there is a problem, and that is at this point. That means when the timer expires and no acknowledgement received for this 2 yet, the sender will understand that some problem with this one, and I'm going to retransmit. And what the sender is going to retransmit, what is the last frame sent, that is 8. Go back, okay, go back from this point, some n position. This n is something that sender window size, like that we will choose the sender window. So here it is 7, so 7 places back, and that window as a whole you retransmit. So go back n, this is the this is how the protocol is getting that name. From that point, go back n position, and those n frames together you retransmit. But here it is like whenever I am getting a negative acknowledgement for 2, or its timer expires. Normally timer will be expiring a little bit later only, but if you are sending negative acknowledgement, the process will be faster, right? So anyway, whenever I locate that the 2 is having some problem with negative acknowledgement or the timer expiry, I will selectively retransmit this 2 only. I am just selectively just retransmitting this 2 only, right? So that is why this protocol is called selective reject or selective retransmit. So this negative acknowledgement, in that way you can expand it like reject. Selectively the rejection is happening, and which is retransmitted. So selective retransmission, or selective repeat, or selective reject. So in 3 ways you can expand this R in the SR protocol. So this can be selective reject. See, 2 is rejected selectively, and when it is rejected, it is retransmitted, selective retransmit, or selective repeat, retransition, otherwise repeat. So selective repeat, something commonly used name for this protocol. And now when it is retransmitted, what will happen at the receiver side? This 2 is coming. Now the receiver is still having some more complexity, because this, it has to look at the sequence number, and it has to put this 2 at the right order, like this 2, then 3, 4, 5, like that it has to sort, and everything it has to deliver to the higher layer. So that much effort the receiver has to spend. Okay, so that is something more about this SR protocol. When we discuss, we will see that. So whenever the receiver is receiving that particular frame number 2, so now see what is the thing. 3, 4, 5, everything received fine, and it is waiting for this 2. Yes, when negative acknowledgement reached, that 2 is selectively coming to the receiver, and now the receiver together will acknowledge all these 3, 4, 5, 2 by sending the acknowledgement for the last one, positive acknowledgement for the last one, ACK 5. But if you are providing acknowledgement number to be the next expected sequence number, then the next expected one is 6. So you can give it as 6. But you can follow any method. So this is a more, in most of the textbook I find it like, and this is a general accepted concept. But if you are giving 5, that also fine. Okay, because we just want to identify that this is for this. You can either identify it like this acknowledgement number is for this particular frame, or you can say that this is the next expected frames. But that next expected frame, that concept is mostly used thing. But see, in the Tunnelbaum textbook, it is explained like this. because they are not giving much attention in that direction. So what they are trying to say, the effect of receiver window when it is 1 and when it is larger. So when it is larger, it is found to be a better protocol, right? So definitely it is better, but it is a costly solution in that sense. Not only this buffering, that ordering and that selective repetition of the, because already it send, so the window will be something like this. From that window, this 2 3 4 5 everything sent. So at the sender side, some complex searching is needed, like it has to locate this 2 from the window, and that 2 is to be selectively sent, and at the receiver side some complex sorting is involved. So anyway, both together it takes some time, right? So that is the difficulty we are facing with the selective repeat protocol. But when it comes to go back N protocol, of course that discard and retransition, so it will increase the overall traffic. So it is not much good protocol, but it is a cost effective solution. This much complexity is not involved here. So whether you want go back N or selective repeat depends on many other parameters also, the costly solution you want or not, or whether your communication media is more error prone or not. Because if it is less prone to error, then this kind of situation will rarely occur and it will work fine. But the chances of error is very high every time you have to retransit the end frame. So that is going to be a highly inefficient method. So depends on the type of communication media, you can choose either this or this. Okay, and we will see more into this. I think we can break this video here, and we will see this go back maybe in the next session.